The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Our next presenter is Dr. Kevin MacDonald from Beton Consulting Engineers. And Kevin's topic is when structural concrete is architectural concrete.
Our moderator has written an excellent paper on what it means to have a 100-year design life. The answer to which is he doesn't know either, and because I don't. And so you should look it up. But you may think that might be an easier thing to do after you look at some of the world of people that are making concrete that is both at the same time meant to be seen and to do some work. So, construction's an interesting thing where you often have to deal with conditions that maybe you didn't anticipate and that the architect may not have envisaged or the structural engineer may not have envisaged. The difficulty that we run into is this acceptable? Now, I gave you an easy one, right? Probably. Just get enough caulking and it depends where you are. But no, of course we may have some thermal problems with that window. But let's take a look at some ACI definitions. ACI has a definition of structural concrete, and that definition is concrete that is going to be exposed permanently to view. So let's stop for a second and think about all the concrete that's exposed permanently to view that is not specified as architectural according to the definition, and this is the Architectural Committee's definition. Concrete that is exposed to view is architectural concrete. Hopefully, concrete that is identified in the specification as architectural concrete is all you're ever forced to construct. But we'll take a look at a couple of things. Structural concrete is plain or reinforced concrete that's meant to carry gravity, lateral or combined loads and put them into the soil. So pretty straightforward stuff, right? How could we ever have a problem? This is a very nice looking floor, as long as you don't look too closely as the owner does and sees a little bit of crazing. And has felt that I paid an awful lot of money for this floor and it really looks really kind of good, but it's these tiny little cracks which a petrographer assures him is the start of the mass deterioration of the interior slab due to forces beyond our control. And as a result, the best thing to do with this office building, which is now occupied, is to remove and replace the slab on grade, because this is architectural concrete. Now, it's interesting enough, you go to look at the project specification, it doesn't have the word architectural concrete in it. However, is this architectural concrete or not? It depends what your lawyer tells you. So this is a bit of an issue, and of course we can get ourselves deep in trouble in construction and not know quite where to come out. I don't know how this fits into the Kiewit manual, but it's probably not well, right? So often we have concrete doing two things. Here's a very boring piece of concrete from Toronto. It's a bollard meant to prevent you from driving into the pedestrians. And in this particular case, it's in fairly good shape. It's exposed aggregate, right? Architectural concrete. This is the next one down the line. It's having a harder time, and it can't be salt exposure because they're both exposed to salt. It just proves that when you're precasting, just like when you're making ready-mix concrete, the batch before doesn't necessarily mean anything about the batch after. So we have to understand that as structural engineers, most of the time we're writing specifications. We're writing structural specifications, right? We've taken all of this data that has been in existence for a very, very long time, and we looked at it, and it's been validated, and here's some great stuff. And this is the origin of the of one of the equations in ACI 318. Straightforward, right? Architects, and I was astonished as you're going to be, they don't have these kinds of equations. They have a feeling of what the structure was imagined to be like when they sat down and discussed it with the owner. They may or may not have a memorandum. Many, many years ago, I worked on the hockey rink for the for the Ottawa Senators. And that structure had exterior precast. And I used to go to the construction meetings and they would say, who has that coffee cup of that terracotta color that we wanted the precast to be? We then got an inspection job to inspect the construction of the precast for external quality assurance. So we wrote our specification our proposal very carefully that said we would check and make sure all of the structural stuff was there, but we're not architects. What color is that concrete? It's kind of like a red-brown. I don't know what terracotta is. I know it means cooked earth in Latin, but that's just because of my bad education. So I said, well, we're not going to pay any attention to that at all. And it's the only construction site project I ever bought. They have 5 beds. And I don't have the photograph here in the presentation, but if you look at it, you can see each day's casting because there's 5 slightly different colored panels all the way along. The architect was adamant that they be torn down. The general contractor asked the owner if it was okay if they gave them a credit. The owner was happy with that, and the architect was not. So this is a pretty robust piece of concrete construction. It's a stadium. It carries lots of loads, lots of cantilevers. You can see the stadia just moving along from the right-hand side. This is a good example of structural concrete. But you're going to find out that it also is architectural concrete, unbeknownst to everyone who was constructing it. Now, it's good of us to look at the world, and remember, I'm going to give you a bunch of anecdotes. But Ward Malisch, we had a tribute session for him a couple of conventions ago, said that the biggest problem that we have is that between execution and the specification is ambiguous language, unachievable tolerances. My favorite is that the concrete has to yield exactly 1.000 cubic yards, which is more units of more accurate than I usually know the specific gravity to. So it does a good one. And I usually ask people, what temperature do you want it at? Because it makes a difference. And then it is anecdotal justifications. We want to make sure that terracotta coffee cup is the right color. And so that leads to lots of problems, right? Because the plural of anecdote is not data. Engineers live by that type of thing. But the owner and the architect don't have the either pre-existing or educationally installed mental defect that they just want to measure things. People want to understand what's going on. And you could lead to the other problem, which is causation and correlation are not the same thing. This is a very useful statistic that means that we should stop using lemons in beer. But anyways, finally, we know that a failure only occurs for 2 reasons. When I was a young man, I heard Brian Mather give this presentation. It only occurs because you failed to follow the specification or the specification was wrong. If only. But that is, deep down, it's coming down to what did the specification say? Because more and more frequently, we're seeing normal slabs that are contracted to meet a generic, meets the 318, 301 requirements, going to give you a nice structural slab that's going to resist the loads, but it has the types of defects that are normally encountered. And then you go and you polish it, and all of a sudden, we're in this situation. The floor is not immediately flat. There's a typical type of defect. Then now you have to either grind that entire slab down another 1/4 inch, which will expose the coarse aggregate, which will give you a different look. Or you could grind this wood locally, but you can see they're putting levels on things, so they'll catch that as well. This was a slab where the standard of acceptance was we wanted our slab to look like the slab of the grocery store here in town because we liked the way that it looked. A phrase you could not find in submittal or in the specification, but that was the standard to which it was held. It would have been useful to have communicated that. Here's another one, back to our office building. If you polish the floor after the walls are up, you cannot polish immediately adjacent to the wall without taking heroic efforts. This is not necessarily a defect. This is a sequencing problem, right? Grind, then put the walls up, not the other way around. And then we get this. This is one of my favorites. Do you see there's an area right near the joint where the particles suddenly got bigger and there's a difference? Do you know how to do that? Oscar, you know how to do that. Have somebody step in the concrete during the placement right after it's been struck off, so their boot drags up more coarse aggregate and you get a slightly different coarse aggregate distribution, and lo and behold, you get this unacceptable architectural defect which requires removal and replacement of the slab. It also goes along to be fairly interesting. This is a photograph of a residential driveway in Minnesota. The residential driveway in Minnesota has some pop-outs. It also has a very nice broom finish. This is 2 years exposure to a place where it snowed on Sunday. And so we look at it, regular plain old driveway, right? It's got some pop-outs in it. This driveway, I'll have you know, is permanently exposed to view. Therefore, during the litigation, it was explained that this is architectural concrete. These are unacceptable. The really scary part is that this material meets the ASTM requirements of C33 for Class 5S, architectural exposure aggregate. But it apparently not if you didn't like pop-outs. I mean, I do some work on the side on occasion, and, you know, beauty is in the eye of the beholder. This one certainly makes the houses in Louisiana seem a little bit more stable. And for the most of the time, the structural concrete was never meant to be seen. You can see here, you can even get a good idea of what the construction method was just looking at this. So we end up having some problems, and what do? So, well, it's simple. You don't use gravel. You use 100% crushed bedrock, and then you get time-release exposed aggregate finish. The impressed surface there is the award winner, the grand award winner for, I think, 2004 for the Wisconsin Concrete Association. I don't have any photographs. It was a big gala. All the salesmen from the company that I worked for went to the dinner and lots of handshaking. I only got to see it the next summer, after it had been exposed to freezing and thawing and had been constructed with non-air and train concrete. But who's supposed to be paying attention anyway? Similarly, these samples are the top and the bottom of samples cast in petri dishes of pigmented concrete. You can see on the bottom, they vary in water cement ratio for a fairly wide range. The bottom is not too far off, but the top is because of the efflorescence that occurs at the surface. And there are ways to avoid that efflorescence. They're just not all easy or cheap. And certainly, I'm going to tell you to learn by experience, do not stand on a homeowner's pigmented and colored and stamped driveway and say it's fit for the intended use. It will support the imposed loads. What are you worried about? Apparently, that is insensitive of me. So, more and more we're seeing slabs on grade that are being treated this way. This one happens to also have a little bit of a problem where we put an epoxy on and there's some other issues going on. But more and more frequently, this was a structural slab specified to be such and then treated for architectural purposes. But it's not just those. This is a warehouse that we looked at where the surface is unacceptable and requires milling. So we looked at it, and well, it didn't look all that bad to us. We took another close look at the surface defects, and these are very interesting surface defects that occur in concrete. You can cause them by dragging something over the surface while there's sand and grit and all sorts of other things on there. Certainly not part of the finish. Similarly, if you're putting a slab into a building where the existing walls occur, it's also pretty hard to get the finishing equipment, power equipment, up immediately adjacent to the wall. OSHA would probably be upset if you flipped over a couple of finishers by removing the guards on the blades so you could get the blades that close. And as a consequence, you end up with this differential appearance. Well, let's go back to that stadia that I showed you and take a look and see what happens. This is a nice day on the site. It's always a nice day when it rains. and the structure is not enclosed. And you can see that not only is the structure wet, but it has some cracks in it. Now keep in mind, it's a reinforced concrete structure. You happen to be at this point near a negative moment area. You probably designed it to crack at some point in this area. Otherwise, you're spending an awful lot of money for steel that you probably don't really need. But this wasn't the problem. I mean, the cracks were bad enough. But we have a type of sand in the Midwest. And everybody has their own problem. So our problem in the Midwest is that we have opaline shales that will react with the alkali and the cement to give us alkali-silica reaction pop-outs. This is what they look like. It appears to, if someone had taken a shotgun, loaded up with salt, and fired it at the surface. I tell people if you go to Florida, you pay extra for a rock salt finish. Here you get it for free, but they're not happy. And the number of people who walk into, this is a bad crowd to ask, but if we went on the street and said, how many of you look down at the slab when you go to an NFL game, you'd probably get, what are you talking about? What's a slab? Right? So they were concerned that people were going to see this and it was not going to look good. And so there was a great deal of effort going to skim coat these and then bring in a very light polisher and do everything else onto a floor which they're going to spill ketchup and mustard on, both of which are acidic, right? And are going to nicely etch the surface. So the ready-mix producer came in and said, well, it's well known that this problem can happen from time to time. And we did tell the general contractor, and this is a good one, that you have to take water and vigorously flush the surface so that you wash the alkalis that are concentrated by evaporating bleed water away. The contractor has just one question. Where does the water go? And then you say, that's not my problem. Right? You just take a whole bunch of water that you've now washed and you're telling you it's full of alkali and just let it rain down on the workers. We'll see if the retirement timing that we saw doesn't accelerate from that. So anyways, we can't have that. But it was very interesting because no one had read the specification. And the specifier was fairly experienced in this area, and they had written that there shall be no particles in the aggregate that cause surface pop-outs. They had told the contractor what the acceptance criteria was. The ready-mix supplier, we were engaged to help them out, was not very happy for me to read the specification and say, have you seen this? And they said, well, that's impossible. Well, no, it's not impossible. Impossible is great. Get relief from impossible. It's just really a little bit more expensive than you thought it would be. That you can't have relief from. The key to getting what you want for architectural concrete, or for structural concrete that's architectural, is to have a clear, unambiguous specification. And there's lots of standards. This is the polished concrete standard of how to measure the gloss, how to measure all the properties of it that you need. So I'm going to give you a happy, feel-good story for the end, because this is how it's supposed to be done. We were engaged to assist in the design of a reinforced concrete parking structure that has parking all over the place with lots of salt, therefore lots of durability. It's a 75-year design life for you, Oscar. And so we had some strange concretes in there. And in the interior core is several levels that are being used for retail car rental. The architect wanted all exposed concrete. And they worried a great deal about how to put things together in the specification. They talked about specifying the plywood, but they could never say, well, what is that going to look like? And of course, the answer is it depends who gets the work and who a ready-mix producer or what they use you can meet the MDO or HDO definition for plywood, but you can meet that definition and get a different image. And so this image shows the soffit exposures for the mock-up. And this image is the wall exposures for the mock-up. Different mixes, the SCC and a high slump concrete, different formwork panels, and as a result, these panels, or these members incorporated into the work, are the on-site acceptance criteria. So here we came out, and that's a nice looking wall. And we had an interesting discussion with both the architect and the structural engineer in the room with the contractor that said, don't go and find your 5 best finishers unless you plan on having them do all the work. Do what you would do like it was a normal pour, because you're going to set the acceptance standard. If you find you need to change your techniques, that's great. But what you don't want is to have a condition where where you put extra effort into the mock-up, because then you have to put extra effort into everything else. And you always go back to look at the mock-up. And it's not perfect, but it allows you to do things like this. So there's the wall, and you can see the lift lines and some areas of blading. That's not in the mock-up. So you can have a discussion and say, what happened here? This isn't in the mock-up. We need to take effort to prevent this from occurring, rather than waiting until the structure's up and then looking and say, I don't like the way that looks. Well, we can sack rub it. Yeah, I'd rather maybe we should remove this wall and re-pour it. You have to be careful in the construction execution. This is where you can see one of the joint panels stuck. You got some fins that are protruding between the formwork panels. You got some chipping on the concrete. Very difficult to repair. So you have to have that standard. This is the mock-up. Again, it's not perfect. It doesn't have to be. The architect approved it, saying it looks pretty good. We'd like you to try to avoid a few things, and one of them was if you could get these screw holes to be less pronounced. And they explained that it will get better as time goes by, which really meant that they would actually put them all the way into the plywood, but that's where we go. So if you come up with a defect like this, you can say to yourself, is this what the mock-up showed or not? And there's no, it's unambiguous, right? You don't have the committee of a small farm co-op saying, we wanted it to look like the gas station down the road. Well, did you put that in the documents? No, but we talked about it a lot at the board. And so you've got a lot of personal pride involved. Of course, you have to be careful. And this is a very nice piece of note that's been left up there telling you that this is finished work, right? Once it's out of the hands of the contractor, it is pretty hard to protect. Does anyone notice how they've fastened those rails to the wall? Right? It must be magic nails, right? So when they come off, there will be spalls. So it becomes very interesting that who's responsible for protecting the finished work. Because I don't know. I put this photograph up because of the note, and then I looked and said, oh my goodness, they fastened these things with nails. This is a gouge from removing the shores. You know, it's not simple work, as many of you know, and as you can lose control of something. It came down and it scraped a very nice looking piece of concrete. If this was in the non-architectural portion of the structure, yeah, well, things happen. Here you've got a big problem. We also ran into the fascinating problem of my concrete is blue-green, and it was not expected to be. Now, the mock-up was also blue-green, but they didn't look at the mock-up for 2 weeks, at which point it had no longer blue-green. And so they sent us a note saying it's blue-green. And I said, well, if it really, really bugs you right now, you can get some hydrogen peroxide and spray it on the surface, and it'll go clear. Or you could wait a couple of weeks. You think that'll go away? Yes, I know that will go away. So you have to be careful to set those expectations, particularly with some of these structural concretes that are now containing high volumes of pozzolan. They really get into the forms very nicely. So you have to look at the quality of the form. But things like different colors from the slag and changing colors, and all of these walls were placed with SCC with an elephant trunk and a Tremie method, but you are still seeing some air bubbles, which makes you think maybe they didn't do the Tremie the best in the world. You have to set the standards in the specification and identify what's architectural concrete if you want to avoid disputes. Thank you very much for the attention.